production has been called an ultra-safe system, but it still has accidents. And increasingly, typically, accidents seem to be the result of complex system interactions. If you take Air France 447, I think it's a classic example where the risk was built in before the flight began, and nothing really changed. You had the same as a technology problem that was well known, weather that was well known, crew, but something happened in the interaction of those factors to make an uncontrollable situation in mid-Atlantic that lost the whole aircraft. Recently in the UK, there was a report on a hospital trust in the north of England, or the Midlands of England, which highlighted high mortality, but what was described as really appalling standards of care. And that was in a regime that had been governed by strict performance standards for many, many years. So the issue is, you know, how can you manage performance in a way that actually fosters an effective culture? Right? And that seems to have radically failed in this case altogether. We've got new regulations, new SMS regulations saying you have to be able to manage change. Regulations have been demanding an effective safety culture. But I don't think many people in the regulators know how to implement this, let alone how to actually oversee and approve organizations in terms of their capability in this way. But I think one of the real drivers of a new approach is this so-called new information age. Right? And I think from an organizational point of view, a couple of developments have become quite acute in their effects on the way in which organizations can manage themselves. All management systems now generate an enormous amount of data. So the real challenge is how to get leverage over that data to manage the system in a better way. Even in the last 4 or 5 years, it's been amazing to notice the change in capability of organizations and their aspirations to actually use and manage data. But this is still one of the most frustrating things, is getting hold of data and being able to manage that effectively. Even this interaction we have now illustrates that actually the technology supports meaningful interaction in virtual communities. Up till now, this has been largely in sort of public space, but very rapidly corporations are taking this over. So it becomes a tool of management, of being able to interact in totally different ways and quite remote ways across systems and organizations. Pilots have iPads, right? What does that mean? Not just in terms of convenience for the pilot, but in terms of meaningful connectivity with all other parts of the system. Formally, system-wide information management systems are becoming sort of standard ways of linking and coordinating, not just within an organization, but between organizations and systems of systems. This is big. I just put this as an example here just to show you that actually, you know, there's big money involved in this. Cesar is just lining up for another 1 billion expenditure on its implementation phase over the next 10 years. Right? So there's a lot hanging on being able to manage those integrated systems. But businesses are changing. Right? We've all seen the lean, low-cost transformation. Right? It raised the issue very acutely. Where are the boundaries of the operation? How to manage? How to change in a way that doesn't undermine your business model? MASCA started because of looking at the high failure rate of change and of implementation of new technology implementation. So we have to look not just at usability of new technologies, but how the whole user group as a social system can implement change, implement new technological systems with a higher degree of success. And increasingly, we're being drawn into companies that are trying to transform their operation, develop new business processes, to develop new collaboration with other companies with which they previously simply competed. But understanding that in managing risk, you have to collaborate as well as compete. And for manufacturers, there's a very rapid process of learning that to compete in the future, they have to deliver services attached to their technologies. So they have to understand the operation they're delivering into. It's a whole new picture that is emerging very rapidly, and we need to be able to respond to it. So the question is, how do complex socio-technical systems actually work? How do they deliver outcomes to meet goals? What influences their performance? How to reduce risk? And how to design such system of systems? How to manage change and regulate them? So thinking about these questions really confronted me as a kind of academic, I suppose, and doing research and teaching in human factors and organizational theory and so on. You know, that's one of the things you look at. So you look at human factors and ergonomics, and you can see that it aspires to be systemic, but it lacks a solid conceptual base for doing that. It's very good on understanding the influences on human performance, but it is actually really weak on understanding the influences on system performance. And that's really teased out in a convincing way. Social cognition tried to broaden the focus. Other approaches like activity theory broaden the focus, but they don't really solve the problem. The reason model, high reliability organization, resilience engineering, all are trying to address a systemic agenda. But I believe none of these have very powerful theoretical tools to do so in a positive, proactive way. Okay? On the other hand, you have process theory, business process re-engineering, process modeling, lean process engineering, and so on. That gives you a really powerful functional framework, linking inputs being transformed into outputs. Very strong on business integration, but actually surprisingly weak in theoretical elaboration. Very few, very limited treatment in organizational theory. Right? And it lacks a developed notion of the human and social role, despite, ironically, the strong social component of participation in improvement initiatives in its Japanese origins. Right? It also has a very strong manufacturing focus, which begs the question how to adapt it to other types of processes that don't have the same technological determinism as in manufacturing. I suppose my own background, organizational theory. Organizational theory seems to address every organizational issue except how does organized work transform an input into an output. Right? This is very ironic. The theoretical range of organizational theory, just to be very schematic about it, seems to vary primarily from a kind of pragmatic management approach to a kind of social, cultural, constructivist approach. We construct organizations in terms of a projection of our own analyses. They don't have any objective, independent existence apart from us. This gives a very strong sort of focus on interpretive methods and post hoc case studies, right? But it lacks the notion of a social system as something that is part of a causal system determining outcomes that delivers reliable performance in socio-technical systems. There's been a growth of influence and knowledge management. Again, the focus is on the process of managing knowledge, the social context of knowledge, ways in which knowledge are transformed. But there is an almost total lack of attention to the content of knowledge, the social technical knowledge that people use actually to manage systems. I could go on at length about this, but here is the first kind of big issue for me, that if you look at that whole theoretical array, there's an amazing gap in terms of a functional analysis of socio-technical systems. And unless we fill that gap, we can't meet that demand. So I think this is maybe the first challenge to you as listeners. Do you agree with that? Does that seem to be reasonable? Because that's one of the first premise that is leading to this analysis. This then leads to the kind of requirements for a practical theory. And for a long time I've talked about relevance and leverage. Right? Relevance means that you need to address the real issues that are influencing what happens. Right? And it's also important not to be wrong. And it's important to say that because it's surprising how often theories actually do give you the wrong conclusion. And they're very rarely held to account. Morton will know that we did a case study on an operational auditing process, and it took a long while to work out that actually that audit came to conclusions that were in some ways the opposite of what was the real situation, because it didn't take into account the operational context in an effective way. So if you'd taken that audit on face value, you would have done things that were quite contrary to what needed to be done to fix the situation. So we need to have theories that are not wrong, right? But theories also need to tell us what to design or change to improve the system, right? And even more possibly, they should actually enable and support the design and change, right? It's easy to say that, but the implications of saying that are that all the theoretical concepts that we have need therefore to be accountable to some kind of core mechanisms that provide the causal and the interpretive explanation. And there's an extraordinary discipline in trying to, particularly for us social sciences, in trying to ensure that those concepts are answerable to some kind of causal explanation or strong interpretive explanation. Right? Even more so then, those concepts need to frame dimensions that can be changed. And if possible, and I think very much our action research framework is trying to support that, the research process should, as far as possible, facilitate implementation of change. And one of the sort of useful paradoxes of this is that actually often when things don't work out well in terms of research, you learn most, because you learn how the system resists different things. But it's really important to be able to prod and provoke the system into action. That's the way you learn how it works. Being psychologists, you know, the core of our human factors people, the core of our kind of knowledge, technology, if you like, is around cognition, sense-making, understanding, and so on. And actually, for many years, the main intervention we were kind of able to make was around training, changing the way in which people think. And for many years, we devised and we delivered these courses that always came up against this thing. This is the way it should be done, but the system doesn't allow us to do that. Right? So human factors was in many situations confined to this ghetto of training that didn't have leverage over how to change the system. Right? So the problem is, how do you actually justify action? Right? So we need to be, in order to change, we need to get leverage over the system in order to both transform the way in people act and transform the way in which the system enables people to act. But we need also to be able to ultimately influence the culture, right, which creates stability. So instead of a cognitive theory, not instead of, but in addition to a cognitive theory, we need theories that encompass the system, the culture, and human action within that. It's complicated. It links functional relations to semantic and meaning relations. It links the individual to the social. Right? How can that be practical? And particularly when you think that the two possibilities for direct intervention are in influencing how people make sense of their situation and changing the system. But really what we need to influence can only be done indirectly influencing action and influencing culture in order to create a sustainable new system. Okay, that's the challenge. If you think of those two avenues of leverage, sense-making, learning, training, communication, collaborative and participative activity, knowledge is a core framework of leverage, right? Influencing understanding and values. If you think about the system, technical, operational processes, social institutions, normative patterns of behavior and action, right? What can be changed in that are things like rules and procedures, the technologies and information systems, even hard technologies have information attached to them, and the social structure. In that change, also data and information and knowledge are also a core framework of leverage over change, and particularly available to us, they are the primary framework of change. Right? So I'll come back to knowledge and information later, but from a conceptual point of view, this is why they are critical. So this leads to the idea of a basic model, right, of how a socio-technical system may work. Right? Okay, it's goal-directed. Right? So we need to understand the goals and needs that are being addressed. It's around a functional process. That's what I've been emphasizing. But it's also around social relations and the notion that people collaborate together in order to produce that outcome. And that collaboration, people work to make a system function. Often, and this has been one of our sort of earliest and deepest lessons, is that the system rarely goes according to the official procedure entirely. If it does so, it is because people make it work. But people also get around impossible situations informally. And that informal action that makes the system work depends upon their established social relations. Right? So social relations are the kind of hidden glue that actually makes systems work. But what intercedes between the functional process and social relations is information and knowledge processes. So at this stage, this is the kind of simplest schematic outline of the kind of approach that we're trying to implement at the minute. And I'll just describe each of these elements a little bit more. Strategy and goals. I don't have a great deal to say about this at the minute, but this is critically important because it links up to the business goals of the enterprise. So it links from the level of the operational process up into the why it's happening and the business drivers of it, and poses the question of the extent to which those goals are clearly expressed as to whether or not they're identified in terms of measurable outcomes, for example, and how far different sorts of outcomes, financial, quality, safety, for example, customer service, how far those are explicitly balanced within the overall framework. But for many years, linking that in, everything has an outcome, but there's a process leading to the outcome. Right? And we've been looking at modeling processes as sequential operations that have tasks transforming a situation to producing an output, going through gates, and so on. Right? That is the basic level of analysis of the functional system that we have adopted from business process modeling. But tying that to a kind of causal analysis, there is that process system. It delivers an outcome, right? But the process system is fed by resources of people, of information and material. It is coordinated by people who have competence, who follow procedures, who show leadership, who adjust themselves to each other, and who are fed by feedback, if you like. And all of this is influenced by context, right? The status of the person, their well-being, other factors, organizational rules and cultures, environmental influences, and so on. Okay? So there's a generic causal influence on the process. But it's not quite as simple as that, because many processes are just not simple and linear. This is an example of a schematic example of part of a turnaround, essentially. Mostly when you look at the turnaround process, you think about the aircraft and the various decision points it goes through, right? But for a ground handler, for a baggage handler, for example, is not involved in all of those decision points, but is moving from one aircraft to the other in a transverse way. So what happens in a turnaround is a combination, a complex combination of many different processes that intersect around certain key gates or decision points. Right? So we're trying to consolidate. Instead of trying to push all the information down into the detail of the process map, that's necessary. That's absolutely necessary to analyze in detail and to redesign the process. But it's also necessary to consolidate that information at a high level, and we think this can be done around key decision points where we can consolidate the process activity, taking into account the preconditions and summarizing the process activity that's led into that decision point, and looking at how that decision is made, what the criterion is, what the outcome is, and how it then influences the next gates, essentially. Okay. So at each decision point or gate, right, it begs the question, how good is the supply of material resources, or of information, or people? How vulnerable are the tasks? How effective was the coordination? Because what we want to try and measure is how variance or deviations or any other unwanted outcome are propagated through the system. So if anything goes wrong, can it be recovered? Does it violate a rule? Or will it just simply be transmitted to the next gate? And if you look at the whole process, how far can you predict that variance will be propagated through it? So the process, it's transactional. It provides a value that can be exchanged at the end, right? It transforms the resources into an output. It has minimal requirements, that things are sequential. It operates in real time, right? And the key issue we're trying to control is uncertainty. Right? And within uncertainty, if you look at the model, there are four basic sorts of uncertainty. Right? One of the things that took us a long time to understand and work in aircraft maintenance was that actually supply of resources is the main uncertainty. It's obvious in retrospect, but for years we were working with managers who were trying to create a perfect maintenance check without understanding that actually if you create one perfect maintenance check, it sucks in resources from everywhere else and undermines the whole system. In coordination, in the turnaround process that I've been talking about, it's not necessarily obvious where the key points of coordination are and what people actually do, which is rarely written down, to make that process work. So the fundamental logic of uncertainty in these processes are not, in our experience, necessarily very obvious to those involved, but they're key to understanding risk. I talked about the team, the social relations. You can map that in different ways. Social relations have a different dynamic from the process. They're longer timescale, enduring relations, sustained value, right? They are the basis for effective coordination. relationships are reciprocal and develop slowly. Right? So the key issue here is social cohesion and the development of trust, right, that creates the possibility of enduring relationships. Information flows, right, have a third logic, right? Here's just different sort of patterns of normative interaction around a turnaround process. Information and knowledge in our model give the possibility of change. Right? Knowledge and information mediate between the functional system and social relations. In next week's talk, I'll expand this a little bit more, because in a stable situation, they're taken for granted. They're not usually the issue, but they're there all the same. There are two key mechanisms here. One is around the identification of data, its transformation of information and knowledge, and the other is a kind of human cycle of transforming tacit to explicit and back into tacit knowledge. Knowledge works, again, in a different way. It requires validation and feedback in order to ensure that it is effective and appropriate. And it helps understand the past, it links what's happening now, and enables us to anticipate the future. Right? But critically, it tells us what the system is doing, and it enables us to understand whether there's shared understanding of values. Those are, very briefly, the kind of core parameters of the theoretical framework we've been developing. If we can implement them fully, as we are doing, it provides a research framework that is fully embedded in operations, that becomes more predictive, as well as being interpreted, and is testable. But what is more important is that it provides management with a capability of more effectively managing performance and understanding and managing risk, managing change, and being able to get an angle over culture, which is critical in developing stable systems in the future. Right? But for designers, it gives a possibility of designing for operations, for designing new relationships between commercial partners, and designing and delivering and implementing complex systems of systems. Those are the goals that we're trying to fulfill. If you think about those goals, the theory has to fulfill quite a lot of different things. It has to be complex enough to address the scale of the problem, but it has to be simple enough to be usable. It has to keep close to the core theoretical mechanisms. It has to be clear enough to link to operational data. It needs to be flexible to apply to diverse situations, precise enough to be modeled, rigorous enough to be testable, robust enough to provide reliable guidance, but through all of that, it has to be stable enough to maintain coherence, right? If it can do all of those things, then maybe it can be implemented and tested in practice. This is a model, a development, a theoretical approach that has taken quite a number of years to develop. It's built upon the work of our group, a whole range of PhDs and projects and so on and so forth, perhaps too many to mention individually by name, right? But this gives a snapshot of where we are and the sort of ideas that have driven this development. I hope next week to be able to actually say a little bit more about how this kind of approach enables us to have a bit more leverage over things like change. That's it. So I don't know whether that sparks any comments or questions. Over to you.
Brilliant. Thanks, Nick. That was brilliant. Very good. Any questions?
Yes.
Will you be able to send out this presentation?
Yeah, what I'm doing, I'm recording this presentation, the slides and Nick. So I'll send the recording, and then Nick can send the slides. So we'll send everything afterwards.
Ah, excellent. Thank you.
Okay. Sorry, someone had a question there?
it's a lot to get your head around, and it's and it's you know, the idea is that there are underlying mechanisms here that need to be sort of identified and kept to, and if we can do that, we can then do interesting things with them. But it's difficult to have a without getting into very difficult concepts, a sort of discussion about these issues. But anyway, I'm really open to comments, because it's, in my view, it's quite a contrast to the way I was taught to do psychology and human factors and so on. And so I wonder if you find that equally challenging.
And
Nick, just a small input. I think it was a nice presentation. I even starting to understand scope, so that's a big step forward. But I think it's you know, it is good, and I think the interesting issues here is that perhaps in this case we can actually see how, you know, theory works in practice, and I think that is really the interesting thing, because we have the opportunity to actually test it in several different systems and see how it works out. Because as you're saying, I don't think that the current theory is really working when you put that test to it.
Yeah, that's the idea, is to, yes, make theory work in practice, and to so that it becomes not just theory, but something more important than theory. Mm-hmm.
And what's interesting, we talked about these key decision points. So basically, it's trying to control the uncertainty.
Yes.
Which,
I think uncertainty is becoming quite a key explanatory principle, and I think it lends itself then, you know, as we'll see in a future presentation, it lends itself then to looking at risk throughout the system, and the idea that what you're trying to do is to manage risk.
Yeah. And like, just what are the challenges in terms of capturing that uncertainty at decision points? I know with the model in relation to resources and competence, and but
yeah, the challenge is that I think there are certain. I mean, I think one of the sort of interesting things is that there are certain sort of standard, sort of built-in features of uncertainty in different sorts of process, right?
Yeah.
Thus, I think a kind of aircraft maintenance process or any other maintenance process is radically different from an operational process, precisely because of the uncertainty about resources, right? And a process like a turnaround that requires lots of parallel activities interacting together is again separate from that, and has different sources of uncertainty. So that's one thing to understand, and it's been a surprise to us really that those basic dynamics of the system they're working in are not that obvious to the managers and others working in that situation, right? That's one thing, right? But then I think the issue is getting beyond just that, those standard aspects of uncertainty, to be able to actually understand in the real dynamic environment what the uncertainties are you're actually trying to control and manage, right, within that.
Yeah.
Okay? And there the challenge is to try and look both in a smart way at the data you have, not just at the outcomes, but the inputs as well, so that you're managing the operation as a whole and understanding how that works, right, is one thing. But secondly, that we have a smart enough analysis that links to things that are not easy to capture in data, things to do with the quality of the team and the flow of information and the common understanding. Those kind of things are also factors that influence the outcome. And they need to be captured in a different way, right? But it's important that they're done. And I think this is the aspiration, that we can build a big picture and show all those influences on risk, and to show that all of those things are things that need to be managed, and can be effectively designed for.
Yeah, okay, thank you. Yeah. Any other questions for Nick? No. Okay, Nick, thank you very much for that. And
thanks for all your patience then. Okay?
and we'll send you the recording and the slide this afternoon. Sure, so that's this afternoon. Okay.
Okay, thanks very much indeed.
Thanks.
Thank you.
Thanks, bye.
Goodbye, everybody. Bye. Bye.
Thank you.
Bye.
Thank you. Thank you.
Thank you. Bye.
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 Bye.